So, hey friends, this is the last part of the tutorial, and we're going to look at testing, talk about Isar DB and security and deployment. Let's look at testing. So we'll start by, in the test folder, we're going to create a new file called Isar DB test.dat. We'll start by calling the main function, which is our entry point, create an object for Isar, and also create an instance, a variable of type directory. Great. Another thing we're going to do is call the setup function. This is inbuilt. This will allow us to initialize our instance before we proceed to interact with the test cases. So we just need to import the Flutter test, which is already there. Let's just add it in our file. We're going to initialize our dir test with a temporary location using .systemtemp.createTempSync. Then we're going to initialize the Isar core, which we'll need in our testing process because we're not dependent on a specific platform. And then we're just simulating the same logic that we had in our main.dat, where we're first checking if isar.instances is empty. That's when we proceed to initialize our Isar instance. We're going to add all our schemas into the instance when opening, that is. And then for our directory, we're going to pass in dir test.path and then give the name of our instance, which is expense instance. Now that we have that, we'll proceed to create a test case. We want to check if the instance has been opened. So open an instance on the Isar database. We want to check if it's actually open. So I'll create a variable called isOpen is equals to Isar test.isOpen. We're calling that method. So we're passing in what we'll get, and we're expecting it to be true. So let's try and run the test and see. So our test has passed, so we have initialized correctly. We're good to go. We're going to create group tests for this, specifically for the budget collection, but you can duplicate it for the rest of the collections. And in our group, we're going to first start by arranging where we're going to create a budget object, a simple budget object that we're going to use within our test cases. Great. Now that we have that, let's start with our test case, which is create a budget object. So we call our Isar test and call the rate transaction method. Then we're going to proceed to add the object that we've created in the budget collection. So we have acted. So now let's assert or verify this. So we're creating a simple variable where we're going to pick the budget using an ID, and we're expecting the ID to be 1 because we've just inserted one budget object. So we're expecting that object, the ID, to be equal to the budget .id that we created above. I hope it makes sense. So they should be equivalent. So if we run the test, it's working. So we're good to go. Let's work on the next test. But before that, let's just clear our budget collection so to make sure we're just using one object within the budget collection. We're just controlling how many budget objects can be in the budget collection. With that done, our next test case will be to read the budget object. So we're going through the CRUD operations. So inside here, we're going to start by arranging, where we're going to create a budget object using the write transaction method, as simply as isar.test.budgets.put, and then we add the budget object that we defined at the top. Then we're going to act, which is we're going to call the object ID of ID1. So that's the retrieved budget object that we have. So what we're expecting now, we are asserting what we're expecting is that the retrieved budget dot amount is equivalent to 100, whatever we designed. And also another thing we're expecting is that the ID of this new variable is equivalent to 1. So let's test that. Because we had set it to 100, it failed. But now that we have 1,000, it has passed. Now let's work on the next test, which is update budget object. So we're going to have a variable or updated budget of type budget. Then we're going to proceed to put or to create a budget object in our budget collection. Now, as an action, we're going to proceed to change the amount to 2,000. And then we proceed to put or update. Remember, update and create use the same method, put. So what we're doing is we're getting defining update budget is equals to isar test.budgets.getID. We're expecting only one budget object, so the ID should be 1. So we want to check if the updated budget dot amount is equals to 2,000, what we have updated. Then we're just clearing the budget collection again. So it should be 2,000 and not 1,000. So it has passed. Great. Let's work on our final operation, which is a delete budget object. So as usual, arrange. So we're going to first insert our budget object into our budget collection. Then as an action, we're going to delete using the delete method in the Isar collection. So we're deleting based on the ID. Now to assert, what we're going to do, define a variable called deleted budget is equals to, let's proceed to go and call a budget object where the ID is equals to 1. Find first. So what we should expect is null, right? Because we've already deleted that. So we're saying expect, we're passing the deleted budget, but what we're expecting is null. Then we just proceed to clear our budget collection. So if we run this, our test has passed. Great. So we have all our CRUD operations done. Great. Let me try save. I can set it once. The range of concept, because what we're using is arrange act assert AAA. Not sure if it will pass. Let's see. So for tear down, it's also an inbuilt function in the Flutter test. What we're doing, it helps us do is once all the test cases are done, for tear down, it's when you want a certain logic to be executed in every after every test case, and then there's tear down all if you want a specific logic to be executed after all the test cases have been performed. I'm just trying to see if it would work. No, it's not working. Okay, let's just make sure that just return the logic as it was. Now we are okay. So let's call our the tear down all function, which is also inbuilt in the Flutter text package. All we want to do is that after finishing all the test cases, we will close the Isar instance and delete the Isar DB from the disk or from the temporary location, and all our tests are running. Great. So that's a simple way of actually creating test cases for your project, and testing is definitely important in every project that we do in every project that we do. So I hope it makes sense. You can proceed to create the same for the different collections. So let's have a look at Isar DB and security. So the first thing will be user authentication. So it's important to actually provide the option for a user to authenticate in the mobile application as for security purposes, so that the only way that one can actually access the data that's in the local database is by first authenticating through the app. And one of the best ways, because we are trying to embrace the aspect of what local databases bring to the table, which is access offline, one of the types of authentication that will be efficient for this will be, for example, if you're creating a utility application like the one that we have in our project, will be biometric authentication. And I have already created a tutorial on that, and I'll share the link down below. Next thing will be database encryption, which has been implemented in the development release, the pre-release version of ISA, which is 4.0.0. It's not in the version that we have been working with in the project, so it will be interesting to see how that looks, which is we'll have the option in the process of opening or initializing our ISA, we have the option to actually set an encryption key. So that will be provided. Another thing to look at will be the data encryption. It's optional to actually store, instead of storing plain text in the local database, you may decide that certain values or certain properties, the values will be encrypted before they are stored in the collection. So that's another good option. Another thing will be input validation and sanitization. So for a local database to be what it is, it requires inputs, right? And these inputs come from users. And one of the ways that we allow users to input is through either text fields or even certain actions that they have to choose. For example, selecting from a drop down and all that. But mainly on situations where text fields are involved, it's important to implement input validation and also sanitize to make sure that certain injections are not implemented that may corrupt the Isar database and or the local database in the mobile device. And the most important part of all is don't store sensitive information in a local database or in the Isar database. I think, for example, for passwords, we shouldn't store them in the local database. You may have a property in the Isar collection for password, but you can set it with an annotation of ignore. So there's a way you may have an arithmetic behind the scenes where when the user enters something and you encrypt it, you can actually access the validation or even interact with a remote server as well in this case. But do not store sensitive information that can be easily accessed or read from other apps within the mobile device. Now let's have a look at deployment. So for deployment, there's some few factors to consider in the process of deployment, even in a local database. I do understand because Isar database is a local database, it might not be something to consider. We mainly think about these things when we are interacting with cloud databases, but local databases are as important and as good as the cloud databases because they do have a specific role that they're applying. We talked about the use cases, right? So first thing will be database versioning. As your app evolves, the database schema changes. The changes might occur to it. So it's essential to handle database versioning properly. And Isar Database, the official site, provides that explanation much better on how to ensure smooth upgrades for existing users without compromising their data that has been stored in the Isar database. Another thing will be backup and restore. Users might switch devices or reinstall your app, and that's why you find in our app expense tracker, we had an option in the home screen where you can allow the user to synchronize or back up their data in short, because that's data synchronization, mainly the export to Firebase is an example of backing up. So providing a backup or a restore mechanism helps users retain their data, and this can be achieved by enabling cloud backup as we did with Firebase. Another thing to consider will be performance optimization. So efficiently managing the database operation is crucial for performance. And one of the things we already did some of these things, which is like indexing and also providing proper query optimization and asynchronous operations. That's why you find most of our operations that we have implemented in Isar, they have been async. It's not that database doesn't have the synchronous operations, they do, but we intentionally implemented asynchronous so that you can be able to provide a smooth process for the user and not have to for the app not to lag or to have to wait for transactions to be processed, so the user can be able to do other activities within the app. Yeah. Another one will be what we have just come from doing, which is testing. It would be important to perform rigorous stress testing so that to ensure that the local database functions correctly across various devices. It's because we have to consider that for Flutter, it's a multi-platform. We have implemented through on iOS. It's important to also run this on an Android simulator, also on a web app, and also on a desktop because Isar is cross-platform. Yeah. Another factor to consider will be concurrency and thread safety. So mobile apps often have multiple threads accessing the database simultaneously. There's something that we didn't mention is that Isar also supports isolates. So implementing strategies like that can handle this concurrent database access is also important. It's important when you decide to implement isolates where you're able to manage them safely. So that's what concurrency and thread safety means. Another factor will be resource management. So local databases consume device resources, right? Because we are storing this database in a user's mobile device. So it's important to be mindful of the database's size and its impact on the device storage, and also implement periodic data cleanup or offer options for users to manage local data storage. So it's important to also do a check on that in the mobile application. And in the situations where the user, you can even give the option of, you can also give the option of, you can also give the option of the clear data functionality that we added in our settings page, where if the user actually wants to clear up the data, maybe they've been it's a notes app, they've been entering some notes or to-dos, and the year has ended and they just want to start in a clean slate, you can allow them, give them a clear data functionality where they clear the whole data from the app and start again. So that's what resource management is. Then we have offline capabilities. So of course, mobile app often function in offline scenarios, and designing the app in a way that it can handle listening to connectivity and also knowing when the user is back online, you're able to synchronize whatever the user had actually set to maybe a remote server. That's what offline capabilities is all about. Then we also have version control and backups. This is more on the development level, where you're able to implement version control for your database schema changes and not just changing aimlessly. The other one will be error handling and audit tracking. So designing user-friendly error messages is very effective when alerting about database related issues. We showed an example where we implemented try and catch and using the Isar error class to provide for us a message. So we decided to display this message whenever there's an error on a snack bar and calling the exception itself to string. So ideally it shouldn't be that way, because it will display or print out the error based on Isar. So users wouldn't understand what an Isar error issue is. So it would be nice to be able to create maybe a class where you're handling all types of possible errors that they could be. And if a specific error occurs, you're able to provide a more friendlier error message for the user. And lastly, we have documentation and maintenance. This is where you maintain detailed documentation of your database schema. Yeah, it sounds it sounds unnecessary because we're talking about a local database, but it's as important as a cloud database, because actually with a local database, every change counts, because you might make a change where maybe a different type of version of an Android version might crash, or you may end up losing the user's data just because of just a simple change in the schema. So how we handle the versions, how the upgrade procedures are very important, and this documentation will be invaluable for future maintenance and debugging. So I really hope that you've enjoyed the advanced Isar database tutorial. This is the end of it. We've been able to look at all the concepts, and also we're using the latest stable version that we have. And even this time we were able to do some test cases and even talk about the deployment and security factors to consider. I hope you've enjoyed, and if you have any questions, please comment down below. If you have any suggestions, if you even have ideas or even discussions to talk about in the comments below, please engage us. We are a community, and I'll see you on the next one.